All right, so we learned how to analyze functions in x and y. Now we're going to learn how to analyze functions in polar, which is r and theta. First, let's think about symmetry. Okay, so let's say that we have some coordinate in polar that has r and theta. Okay, we are going to take this point and then say, like, is there symmetry around the x-axis? Around the x-axis means that it's going to flip down across the x-axis, right? So if there is symmetry, then that means this part is going to be exactly the same. So that means r theta should equal to, let's think about what this point is. Okay, how do I get to this point? Let's say that I have a positive, r. How do I get to this bottom point? How do I get to this bottom point from positive r? Minus theta.
Reflected.
Okay, so minus theta, right? So r comma minus theta. Let's say if I go in the negative r direction, how do I get to that same point on the bottom? How do I get there? Plus 90. Plus 90 will just be right here.
180. Plus theta.
Plus theta, maybe here, I don't know. Because it's not, halfway, so I don't know.
Yeah.
If I'm at negative r, Freeman, Kim, are you with us?
180 plus 180.
Plus 180 is going to be here. Minus theta.
Yeah.
Good. If you start at negative r, it's going to be 180, let's do pi, minus theta. Okay, so that's across the x-axis. Across the y-axis. Okay, so I have a r, I have a theta. I am going to flip it across the y-axis. So it's going to look like this. Put a dotted line so it's different. All right, so r theta is going to equal to, okay, if I walk across positive r, how do I get to this point on the left? 180 minus theta. Yeah, there is a pattern to this. Okay, let's say that we walk across the negative r. Peter, are you with us? Okay, stay with us. Okay, negative r. How do I get to that same point? Negative theta. I'm going backwards theta. All right, that's around the y-axis. Last one, around the origin. Around the origin means that you're going to take your iPad and you're going to turn it 180, and it's going to look exactly the same, which means actually flip it across. Okay, r theta is equal to, all right, positive r again. If I were in the positive r part, how do I get to this point? 180 plus theta. Yeah, 180 plus theta, so pi plus theta. Okay, last one, negative r.
Minus theta.
Okay, if I'm at negative r, how do I get to that point? Theta. Okay, so plus theta. Yeah? Okay. All right, so there are three kinds of symmetry for a polar graph. Across the x, across the y, or around the origin. So let's go ahead and analyze this graph. So, okay, we have to analyze the graph anyway, so let's just take out your calculator and graph it. You are in polar.
the domain and all that.
Yeah, so I'll show you how to do that, but graph it first. All right, so your graph looks like this. Okay, so let's go ahead and analyze this. We want to figure out the domain and range, but it's much easier to do if you look at the equation and not the graph. Okay, this is r, blah, 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 theta. That means domain is theta. Okay, we're not in x and y anymore. Okay, we used to think of x as domain. Well, we changed it. There is no x, y anymore. There's r and theta. So theta is domain. So let's think about it. 4 sine 3 theta. What can I put into theta that will make sine undefined? What number can I put into sine that will make sine undefined?
Oh, something on that thing that it can't be.
Yeah, right. So what is that?
Like anything past pi to negative pi. Or wait,
Okay, talk to your
no,
partner.
it's
What makes
this
sine
side.
undefined?
This
What makes
side.
sine undefined?
What's
Talk to your partner.
well, I got negative 90, right?
Okay.
Like something.
Cammy all of a sudden has something and she has no partner.
Yeah, I know. Like what you were saying, when, how like cosines one.
That's an
half.
inverse sine, not sine.
Oh.
Okay.
Okay, what makes sine undefined?
Imagine-
Nothing. Nothing makes sine undefined. Nothing makes sine undefined. All real numbers.
What?
Remember your sine graph goes like this, right? There's no x value that makes it undefined. Okay. All right, range. Range has to do with the output, which is r. Okay, I'm going to teach you guys a trick. This is kind of fun, but I think I just like to think through these things. So let's think about sine 3 theta. Sine 3 theta. Sine 3 theta, the 3 in there really doesn't matter. Okay, so sine theta. What is the highest number sine can be? 1. What is the lowest number sine can be? Negative 1. Negative 1. So then the highest number is 1. The lowest number is negative 1. Therefore, what is the highest number of r? 4. What's the lowest number of r? Negative 4. So therefore, the range is negative 4 to 4. Now, when you look at this graph, you're going to say, wait a minute. Really? But this is probably like a number that's smaller than 4. This part where the pedal ends. That is true. However, remember you're looking at r and theta. Theta is how much can you go around this thing. You can go around this thing forever. R is how far out are you from the center. Okay? You're not in xy. You're not in xy. Okay? You're in r, how much out, and then theta. So you're, rotating. All right, so that is domain range. Continuity. What is the continuity? Continuous. Yes. Symmetry. Looking at this graph, what do you guys think? Huh? What kind of symmetry? We just did that x-axis, y-axis, or origin. There's no even and odd for polar.
Y.
Y-axis? Yeah, it is y-axis, but we need a proof. Okay, so y-axis. All right, looking back at your notes. Y-axis. Y-axis, we're going to use this part. R theta equals negative r negative theta. R theta equals negative r negative theta. That means if I put negative r, negative theta in the function, I should get the same function back. Okay, so my function is r equals sine 3 theta. To prove y-axis, r theta has to equal negative r negative theta. So what I'm going to do is put negative r in the function. So that is negative r. And negative theta, sine 3 negative theta. Okay, so then let's go ahead and continue. So this is sine negative 3 theta. Sine negative 3 theta. Let's think about the last chapter. Sine is an odd or even function. Which one? Oh, not cube. 3.
Sine.
Odd or even?
Odd.
Odd. So negative inside means what?
It's the same thing as positive.
As the same. Negative inside is the same as
Negative outside.
negative outside.
Outside.
That means we can take the negative and put it outside.
Do you have to prove that every time?
If I tell you to prove, yeah. Okay, so you can see that negative's gonna go away, right? So then they are the same, which proves that it is y-axis symmetry. All right, so this is y-axis. Okay, boundedness.
Or negative.
Bounded. Yes, yes, what?
Yes, it's bounded.
Maximum R value.
4.
Good. Are there any asymptotes?
No.
No. Okay, if the domain is all real numbers, there's no way to have an asymptote, for the most part. Edward, what are you sending to people? You keep smiling at people, people keep smiling back. And it's like, this size Wimble last time was sunny. Can you stop, just kind of focus?
Attention.
All right, let's have you guys practice. Domain. Actually, let's go down. Okay, Cami, let's start with you. What's the domain? Good. Elizabeth, what is the range?
0 and then 4.
Yeah, 0 to 4. Okay, I know some of you are looking at it and then saying that, that doesn't look like it. Its lowest is whatever that is, highest is whatever that is. That is not true. This is in the XY. Range is how much can you go out from the center. Okay, because that's radius. Right? How much can you go out from the center, which is 0, 0. Okay, so 0 to 4. Bruno, continuity.
Continuous.
Continuous. Oh, CLO symmetry.
X-axis.
X-axis. Let's try to prove that. Okay, R theta is equal to, let me see. R negative theta, thank you. R negative theta. Okay, so that means I'm gonna put R in the equation. The R is the way it is. Equals 2 plus 2 cosine negative theta. All right, let's think about cosine. Cosine, is it an even graph or an odd graph? Even. So the negative inside means what?
Negative inside.
Negative outside is
It stays, right?
No, negative inside means that there's no negative at all. Because,
Oh, yeah, it's all the same.
Same as
yeah,
as it is when it's not negative.
like even function means that, right? So then the negative is just, it goes away. So it's R equals 2 plus 2 cosine theta. So therefore it is x-axis symmetry. Okay, Jim, boundedness. Good. Jingyi, maximum R value. Okay, R equals 4. And then Edward, asymptote. You don't know. Okay. Jingzi?
No.
None. All right, so your homework has 4 analysis questions. And then we're going to now move on to 6.6 for just the first part.
So we're not doing the rest of
No,
Are we going to?
no, we don't have time. Okay, 6.6. Okay, we're now going to go into complex numbers. What are complex numbers? Yeah? Yeah, things with imaginary numbers, right? So remember they have this form, a plus bi. And then a is the real part, and then b is the imaginary part. Interestingly, we can graph complex numbers in a plane. Yeah, we can actually graph these numbers. It's kind of strange thinking about it, but we can. So what we can do is draw an axis where the part that used to be x-axis, we can think of it as the real number part, which is the a part. And then the y-axis part is the imaginary part, which is the bi part. Okay, so when we're graphing a complex number, we're thinking x-axis is the real part, y-axis is the imaginary part. For example, u equals 1 plus 3i. Yeah, so you can just think of it as 1, 3. And then you can actually think of it as a vector. So 1, 3 is right here, u. Okay, v. V is 2, negative 1. So that is 2 and then negative 1. 2 minus I. Okay, this is v. So now I want you to draw u plus v. And I want you to show that by parallelogram or tail to head method. All right, u plus v. So I'm going to do the tail to head method. Okay, so this is v and tail to head, this one. So this is u plus v. Well, since complex numbers can be plotted in a plane just like vectors, they will have the same properties as a vector. So how would you figure out how long this vector is? Well, okay, so let's say we have this thing that has a long, b high. What's
A squared plus B squared.
Yeah, so basically we are going to use a squared plus b squared again. So we call this, to find the length, the modulus. So when they say find the modulus of the complex number, they are asking you for the length. Okay, so a plus bi. Now, complex numbers has a special letter. It's z. So when they say z, they meant complex number. And then so if they look, they have this absolute value thing around it that is telling you to find the length. So that is the square root of a squared plus b squared. Okay, last thing and we're done. Okay, so we have this this complex number that has a and b here, and this is, you know, has a certain length r, and then there's a theta. Okay, this is probably the 5th time I'm asking this question. What is a?
Cosine theta.
R cosine theta. Okay, and then b is r sine theta. Okay, very good. So same thing. A is r cosine theta, b is r sine theta. Therefore, z, which is a plus bi, we can substitute all that in. So we're changing this a plus bi, which is a complex number. Andy, are you with me?
Yes, ma'am.
Okay, you will be. Come back. Okay, so a plus bi is a complex number. We can change it into a r and theta kind of form. So a is r cosine theta. And then b is r sine theta with an I in the back. Okay? I can take that r out. So r times cosine theta plus sine theta I. This is z. All right, so this is the complex number in the trigonometric form. trigonometric form, the trig form. Z is equal to R cosine theta plus sine theta with an I. That is a really, really long thing to write. And then actually, most of the time, they don't write it this way. They write I first.
Should we do that?
Well, actually, I'm going to tell you an easier way to write this, which most high schools do teach that way instead. So Z is equal to RCIS theta. So R6 theta.
Oh.
So the way they do it is RCIS, cosine I sine, and then theta. And then it's just faster to write this way. All right, so this is the way you're gonna write it. We are just gonna do one problem. Yeah.
I just read it as I cosine theta.
Oh yeah, of course. It's just really long.
It's confused.
Okay, that's fine. Yeah. Okay, so let's do one problem together, one problem on your own, and then we are done. And then I'm gonna change the homework tonight because we didn't get to go over everything. All right, so please wait for the remind or read Schoology. Okay, first one, 1 minus square root 3i. So you want to graph it on the complex number plane to see what this vector is pointing to. 1 negative square root 3. 1 and then square root 3. All right, can you find r and theta? Yes, you can. You did it on the woman. All right, so we've been doing this for a long time now. So r and theta. And theta, please keep it positive. Don't make it negative. Both r and theta, we want to keep it both positive. Okay, what is r? 2, very good. Theta is not 60. We can't still be doing 60. 60 is this part from the 0.
Oh, direction. So
300. Okay, please make sure that you don't make that mistake. Okay, r cis theta. So in that form, 2 cis 300. And then you're done. So that is changing from complex number to a trigonometric form. Okay, let's have you guys try one yourself. -3 minus 4i. The answer is 5 CIS 233.1 degrees.